Good evening to all students. Welcome to second series of Magic Revisions. I'm Teacher Tan from College Matriculasi Selangor, the moderator for tonight's sessions. Tonight we are going to have Madam Chia, the pensyarah cemerlang from College Matriculasi Selangor, to conduct her session on Chemical Bonding Part 2, focusing on hybridization's subtopic. Before we start the class, I would like to remind all students to use appropriate language when giving comments in the chat box later on. Without further ado, we shall invite Madam Chia to start her class.
Selamat malam semua. Good evening. So my name is Madam Chia. So tonight I will share with you about the topic 4.3 orbital overlap and the hybridization. Okay, now so before we start the lesson today, sharing today, so we review what we learned in chapter 4. So 4.1 we're talking about Lewis structure. So Lewis structure is how the covalent bond form. So we know it's formed by the sharing electron. So this is a sharing electron happen to form covalent bond. So 4.2 we learn about molecular shape. So what is a molecular geometry of Lewis structure? So where is we predict the molecular shape from the Lewis structure by using the valence shell electron pair repulsion theory. Now 4.3 we learn about orbital overlapping and hybridization. So we will answer how the electron and orbital overlap to show sharing of electron. So now from this picture you will know this is a sharing electron, but you know this electron come from the orbital from Cl, and this orbital come from the beryllium. So since the electron is located at orbital, so how the orbital overlap to form the chemical bonding, which is a covalent bond. So today we're using the theory we call valence bond theory, VB theory. So what's the valence bond theory discuss about is a bond between two atoms is formed when two electrons with the opposite spin pair are shared by two overlapping atomic orbital, meaning that the atomic orbital must overlap. Once they overlap, they will share the opposite spin. So this is mean by opposite spin. So by using the orbital overlap. So 4.3 is like the microscope from the Lewis structure. You can see electron share. And then 4.3 we know where is the electron located. Electron located at orbital. And the orbital will overlap to form covalent bond. Okay, now this is overall 4 case I will discuss today. The first one is simple overlapping. So simple overlapping is using the original S and P orbital. That means what is original, meaning that the orbital is without hybrid. It's a spherical dumbbell shape for the P orbital. The example here, let's say HF, hydrogen, FF, HCl. Okay, now about the case B is one central atom with all single bond. So that means the case B is you can find one central atom, and the central atom is a single bond with other terminal atom. So the central atom will hybrid. Okay, what's a hybrid is hybridization is a mixing of two or more atomic orbital in an atom to generate a new set of hybrid orbital of equivalent shape and energy. So example, S plus P. So they mix together. This one we call mixing together to form the SP and the SP. So SP and the SP. So this one we call new set hybrid orbital. Hybrid, and then where is a equivalent shape? The shape is equal. So second one is the energy is equal. So that's why when you draw the orbital hybrid, the shape is equal size. So for this case B, one central atom with all single bond So you can found central atom were hybrid and the terminal atom were using original orbital to overlapping, meaning that the terminal atom is not involved in hybridization. If a hydrogen using the S, if a fluorine using the p orbital. So this example. Okay, now how about the part C? The case C is a one central atom, but the central atom involve a multiple bond. So for this case, central atom were hybrid and terminal atom involve the multiple bond like double bond and triple bond were hybrid also. So example is like this. Okay, now we go to part D. It's more than one central atom. So for more than one central atom, that means that the central atom, the all central atom were hybrid. Terminal atom involved from multiple bond, double bond, and triple bond were hybrid also. This example. Okay, tonight I will go through from the case A until case D. Okay, now, so I start with the case A first. So before I start with case A, you must know the what is orbital overlapping. So orbital overlapping is a two atomic orbital from a different atom share the same space, Okay, so meaning they overlap. Okay, now when they share the same space, they will form two types of the bond. One is a sigma bond, and another one is a pi bond. Okay, for sigma bond is covalent bond formed by overlapping end to end. Okay, let's say example, one S from hydrogen and one S for hydrogen. This one we call end to end. So later on they will share the space end to end. So this one, the way they share is end to end, we call sigma bond. So this example, S and the p orbital share the end to end, we call sigma bond. Okay, how about the pi bond? Pi bond is how the bond share covalent, how the orbital share is by using overlapping side to side. So where is the side? Side is this part. This part we call side. So this part we call side. So when side to side overlap, they'll become like this. So this is a side overlap. So this one we call pi bond. Okay, so sigma and pi is describe how the orbital share by using the end to end or by using the side to side. Okay, now before I proceed, you must understand the sigma and pi bond. For single bond, is a sigma bond. For double bond, is a one sigma and one pi bond. For triple bond, is a one sigma and two pi. So conclusion, only one sigma for the all type of the bonding. Okay, so one sigma only. Okay, now for case A, simple overlapping. Okay, so I will discuss the simple overlapping by using the HCl. So this is the Lewis structure for the HCl. Okay, this bond represent the electron sharing. So these two electron sharing. Okay, now discuss where is this electron come from and where is this electron come from. So now we check the valence orbital diagram. It's a 1x half 1 electron, and for the Cl is a 1s is located at the spherical shape S, and for Cl, right, the unpaired electron is located at 3p. So that means that it's a p orbital contain the one unpaired. Okay, now so each that means this electron come from 1s and this electron come from the 3p. So how these two electrons share by using the orbital. Okay, now I show you. So this is the orbital overlapping. So when they cross together, we end to end overlap, and then they will form the share the electron with opposite spin. They must opposite spin, and since the overlapping is end to end, so that's why it's called sigma bond. So this is simple overlapping where is they're using the original orbital. Let's say this is an x orbital and this is a 3p orbital. Now, so after we discuss the case A, now I will discuss what is the concept of the hybridization before we proceed to the case B, C, and D. Okay, now, first one, steps to draw orbital overlapping. First one, you must draw Lewis structure. Number 2, determine electron pair, bonding pair, lone pair, electron pair geometry. Step 3, molecular geometry. Step 4, orbital diagram for the ground state, excited state, and the sp hybrid state. So after step 5, you can draw orbital overlapping. Step 6, you can explain how the sigma bond and the pi bond form in the sentence. Okay, this is the first one. Second one is you must know how to determine the electron pair. Okay, as you know, this is a single bond, this is a double bond, and this is a triple bond, and this is a lone pair. For single bond, double bond, triple bond, and lone pair, we consider as a one electron pair. Okay, now for this example, I will show you how I count the electron pair. So first, lone pair, consider 1. Single bond, 1. Single bond, 1. And this one, single bond, 1. So total is 4 electron pairs. Okay, now how about this carbon? Single bond, consider 1. And single bond, consider 1. And double bond, consider 1. So total is 3. So this is how we count the electron pair. So next one is how to determine type of a hybridization of atom. So to determine type of hybridization of atom, it depends on electron pair. Okay, let's say 2 electron pair sp2, 3 electron pair 2 electron pair, 2 electron pair sp. So 3 electron pair sp2, then 4 electron pair sp3, 5 electron pair sp3d. So maybe student will ask, why not sp4? So as you know, p is a px, py, pz only. So p only maximum 3. That's why 5 electron pair is a sp3d. How about 6 is sp3d2. So that means you must know electron pair first, then you can predict the type of hybridization. Now, this is last one is how to predict the orbital diagram of sp hybrid state. So as you know, later on you will write the ground state, excited state, and the hybrid state, right? So I will teach you the tips how to predict the type of the hybrid state you should get. So first step is identify type of hybridization. Second step is identify number of lone pair, sigma bond, and pi bond. Okay, now if one lone pair, make sure your sp hybrid state contain one lone pair. If one sigma bond, that means you make sure your hybrid state is contain one unpair. So if one pi bond, make sure your hybrid orbital contain one unhybrid p orbital. So why sigma bond is unpaired? Because A provide one electron, B provide another electron to form the sharing. That's why to form the sigma bond, you must prepare one unpair so that another electron can come to share a bond. Okay, pi bond also same. Okay, so this is the tips. Later I will show you how to use the tips to predict the sp hybrid state. Okay, now we proceed with the case B. One central atom with all single bond. Okay, now so we start with the basic one is a BeCl2. So BeCl2, right? This is a Lewis structure. We can count. This is a central atom and all single electron, single bond. That means this is a case B. So for case B, only central, hybrid, and terminal is using the original orbital. So now I will count the how many electron pair. Single bond 1, single bond 1. That's why answer is electron pair 2, linear, 2 bonding pair, and no lone pair. And molecular shape is linear also. And this is a type of hybridization SP. Okay, before I proceed to answer the question, you can start with electron pair arrangement, bonding pair, lone pair, molecular Lewis structure, and the molecular shape, type of a hybridization. The last one is a ground state orbital diagram and the overlapping. Okay, now before I start the ground state, excited state, and sp hybrid state, right? So I will predict my answer at the sp hybrid state first. Okay, how to predict, right? So you can check your molecular shape. This is a sigma bond. So as you know, just now I tell you sigma bond must provide one ampere. Okay, so that's why two sigma bond meaning that I must prepare 2 pair. Okay, now we start with the ground state. So ground state for beryllium is a 2s2. So 2s2. Okay, now you can check your expected result is 2 ampere. But the ground state here is in the pairing. So meaning that you must jump 1 electron to the 2p. So make it like all 2 ampere. Yes, so you already achieve your target is a 2 ampere. So you combine, you mix the 1s and p. So why is the sp is a mix with 1x and 1p. So we call sp.
我在看你的 line， 我在电脑看你的 line。
Okay, so you form the empty. So this two is not involved in the hybrid, so it's called empty 2p orbital. Okay, so this one is called sp. So now, so what I teach you today is a predict the hybrid step. So you can in this process you will think whether want to jump or how many electrons you want to promote or anything else. Okay, now fourth terminal is 3s2 3p5. So as you know, 3p5 is 1 ampere in the 3p. Okay, so now I will draw the orbital overlapping. So orbital overlapping depends on molecular shape. This is a linear, so I will show the linear shape. So this linear shape. So make sure you label the center BE and SP, SP. So this is the first SP, which is a bring 1 ampere. This is another SP, which is a bring another ampere. Okay, now how about the chlorine? Chlorine is a 3p. 3p also dumbbell shape. So I will draw the 3p. So overlap end to end 3p. So make sure you CL 3p and label the overlapping sigma bond. So this is another 3p. Okay, CL 3p and sharing, so sigma bond. Okay, done. So this is a hybrid orbital overlapping. So make sure you label the central atom and make sure you label all the sp 3p sharing electron and the sigma bond. Okay, done for electron pair 2. Now we proceed to the aluminium. Okay, aluminium is one central atom or single bond. So only central atom will hybrid, terminal no need hybrid. Okay, now so we check how many electron pair. Single bond 1, single bond 1, 1. So you get is a 3 trigonal planar for the molecular geometry. So 3 bonding and no lone pair, that's why I get trigonal planar. Okay, now for 3 electron pair, type of hybridization is sp2. So now we check how many sigma bond. 1, 2, 3. If a 3 sigma bond, meaning that 1 sigma, 1 ampere. 3 sigma bond, meaning that 3 ampere. All right, so this is what I expect to get after the cycle step. Okay, now we look at the ground state for aluminium. It's a 3s2 and 3p1. So this is what I expect to get 3 ampere. So, but the ground state is a 1 lone pair and 1 ampere, meaning that you need to jump. So you get the 3 ampere. So after that, this is what I want. So I mix the xp2. So sp2 together become the sp2. And this part not involved in the hybrid, we call empty 3p orbital. Okay, how about terminal? Terminal is a chlorine, is a come from the 3p5. So this is ampere we were using later on. Now I will draw the orbital overlapping. So it's according to the molecular shape. It's a trigonal planar. Okay, now I will draw the trigonal planar. Okay, so you label the AL. This one is sp2, sp2, and sp2. So each sp2 bring 1 electron, 1, 1, 1. All right. Now, how about the Cl? Cl is a p orbital, 3p orbital. So I'll draw the 3p here. So they overlap n to n. Cl, 3p. So they bring one electron to share. Okay, here also n to n overlap. And Cl, 3p, bring one electron to share. And this is another 3p. Cl, 3p, and bring one electron to share. Okay, so this is the answer, orbital overlapping for the AlCl3. Make sure you label all the central atom, hybrid, original orbital, and the electron and sigma bond. Okay, now, so after we study about electron pair for the AlCl3, now proceed to 4 electron pair. So 4 electron pair are using the example which is ammonia. So ammonia is one central atom and all a single bond. So that means central atom will hybrid and the terminal atom no need to hybrid. Okay, so we count how many electron pair is 1. Lone pair is 1. Single bond 1, 1. So total is 4. 4 is electron pair arrangement is tetrahedral. So lone pair, 1 lone pair, and 3 bonding pair. So molecular shape is trigonal pyramidal. So since it's a 4, sp3. Okay, now before we proceed, right? So we will target our sp3 hybrid state. So since contain 1 lone pair and 3 sigma. So this is sigma 1, 2, 3. So just now before I start the case B, I tell you the tips is if a 1 lone pair, we'll prepare the lone pair first. If a 3 sigma, we'll prepare 3 unpaired. Yeah, so this is what we expect to get. Okay, now I will draw the N, 2s2, 2p3. So 2s2, 2p3. Okay, now can you check the ground state at the what you expect to get? It's exactly same. So meaning that you no need to do any excitation or promotion. You just copy paste in the ground state to the excited state. Then you mix the sp3. This is what it means by sp3. Mix together become sp3. Alright, so you get sp3. So terminal is a 1s. So 1s, you know, this is a spherical orbital. Okay, now I will draw the orbital overlapping for the Trigonal Pyramidal. Okay, as you know, Trigonal Pyramidal, the shape is like this. Okay, or like this. So you just follow your molecular shape. Okay, now I will draw the tetrahedra. Okay, so make sure you label the N and sp3, 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 and the sp3. So one sp3 is a lone pair. So lone pair is located at the top side. So make sure you label it. And the balance 3 is a single electron. So 1, 2, 3. Okay. Now, how about the terminal is an x orbital, is a spherical shape. So I will draw a spherical shape now. So 1s, H, and sigma bond. Okay, so sigma 1s, H. Okay, so sigma and 1s, H. Okay, done. So it's exactly like the molecular shape, but represent in the more detailed orbital overlapping. Okay, now after electron pair, 4 electron pair, now we proceed to the 5 electron pair. Okay, so for 5 electron pair, I'm using another example where is Ia4 plus, involve the plus. Okay, now I will calculate how many electron pair. So for lone pair equals to 1, 1, single bond 1, 1, 1. So answer is a 5 electron pair. So that means trigonal bipyramidal, 1 lone pair and 4 bonding pair. Okay, since this is a central atom involved hybrid, central atom or hybrid, the terminal is not hybrid because single bond, don't need to hybrid. Okay, so after consider the one lone pair for trigonal bipyramidal, the molecular shape is a seesaw. Okay, now for the type hybridization, it depends to the electron pair phi, so sp3d. So before I proceed to ground state, I will predict what type of the sp3d hybrid state I should get. Okay, now I analysis, this is a one lone pair, and this is a 4 sigma. Okay, so that means I expect to get is one lone pair and 4 sigma. Okay, this is what I expect. Okay, now we look at the central atom is a period 5, 5s2, 5p5. So 1, 2, 1, 2, 3, 4, 5. Okay, so then before you start, right, since the structure contains the charge, you must be careful. So you can count how many electrons here. 2, 4, 6, 7. 7. So you can count how many electrons here. 2, 4, 6. Right? So how you reduce one electron from 7 to 6, right? Okay, now charge, right? So what you can do now is you calculate the formal charge for the iodine. So formal charge for iodine of iodine. Okay, so valence electron 7 minus 2 lone pair plus 1 over 2 bonding electron 2, 4, 6, 8. So you get the answer is a 7 minus 6, you get a positive 1. So you rewrite again the ground state, formal charge positive 1. So as you know, positive 1 meaning that less 1 electron. So 7 minus 1, 6. So now I will write the 6. 1, 2, 3, 4, 5, 6. Okay, now you can check is exactly same 6 electron for your expected and the ground state. Okay, now we check again. I just require one lone pair. This one lone pair must remain. So this one lone pair must split become the unpair. So meaning that this you must jump one electron to the D. Okay, now I rewrite again the excited state. 1, 2, 1, 2, 3, 4. Okay, now already achieved what I get is one lone pair and 4 unpaired. Okay, now I'll mix them together, become the hybrid I want. sp3d, sp3 and 1d. That's why you call D. So this is a hybrid I get. Okay, so the balance, the 4 is called empty 5d orbital. So for foreign is 2p5, where is unpaired is located at 2p. So now for this case, be careful with the ground state, with the charge and without charge. Okay, now we proceed to the next one is orbital overlapping. Okay, this is answer from the previous slide. So now I will start drawing how the orbital overlapping. Okay, class, even though seesaw or T-shape, right? So you just remain the shape like the trigonal bipyramidal. Just remain the shape. Okay, so it's easy for you. Okay, now this is trigonal bipyramidal. So I will draw the skeleton, then help me to draw the shape. Okay, now I'll draw the trigonal bipyramidal. Okay, it's 120 degree, and one more. Okay, so this is trigonal bipyramidal. Okay, now so I will draw the eye. So label as P3D. Okay, then this is a lone pair. So make sure lone pair exactly like the molecular shape, lone pair. And this is a 4 unpair. 1, 2, 3, 4. Okay, now look at the p orbital. The unpair is located at 2p. So now I will draw the 2p. So 2p is dumbbell shape. So I will undergo the overlapping end to end. So label the F, 2p, and sigma bond. F, 2p, and sigma bond. So F, 2p, and sigma bond. The last one. So F, 2p, and this is a sigma bond. So make sure you label all the central atom and the lone pair and the sigma bond. Okay, now don't forget this is a charge, right? So got two ways to label the charge is you can bracket again the orbital overlapping as a charge positive, or you can label the center is a I with the positive formal charge positive. So this is a two way. The first way and the second way you bracket it. So this is for positive charge. Okay, so student, are you ready for proceed to the next one? 6. Okay, come. So 6 electron pair we are using example is for charge negative. Right? Okay, now we calculate first. This is a one central atom. So and all is a single bond. So that means central atom will hybrid and terminal no hybrid. Okay, now how many electron pair? 1, 2, 3, 4, 5, 6. So 6 electron pair, square pyramidal, 4 bonding pair, 2 lone pair, and the molecular shape is a square planar. So since it's a 6 type of hybridization is sp3d2. So 2 lone pair and 4 sigma bond. So how I predict my sp3d2? Okay, now 2 lone pair. So this is 2 lone pair. So make sure it's 2 lone pair. And this is a 1 sigma, 2, 3, and 4. So this is a 4 ampere. So this is what we expect to get. Okay, now we go back to the ground state. It's a 5s2, 5p5, 5s2, 5p5. Okay, now, so just now I mentioned to you if a charge positive and negative, so you must be careful to double check the how many electron with the ground state and what you expected. Okay, so this is 7 electron, but you expect, you can recalculate 2, 4, 6, 8 is 8 valence electron, but what we have just 7. So how I get another 1 electron, right? So what we do is you can calculate your formal charge. Iodine is a 7 minus 4 lone pair plus 1 over 2, 8 valence electrons. So you get answer minus 1. So that means you rewrite again the ground state with formal charge minus 1. So just now 7, now minus 1 means 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is what we get one electron from the formal charge. Okay, now we want to decide which electrons should be excited. Okay, now you look at here. 2 lone pair must remain. Okay, so then I will get another 4 ampere. So that means that this lone pair must spread become the ampere, and this electron also will jump to another 5D to spread become the ampere. So I rewrite again the excited state 1, 2, 3, 4, 5, 6, 7, 8. Okay, now class you can check 2 lone pair, is it? Yes. 4 ampere, yes. So now you did achieve your target 2 lone pair and 4 ampere. So now I will mix them together, become hybrid orbital as P3D2. So this is what I mean by SP3D2. So 2 lone pair and 4 ampere. Okay, so the balanced one we call empty 5D orbital. Okay, now, so terminal is a 3p5 is located at the p orbital. So we're using original p orbital to do overlapping. Okay, so this is answer from the previous one. Okay, now I will draw the orbital overlapping. So we follow the shape is a square, square pyramidal. So I will draw the square pyramidal first. So square pyramidal. So make sure you label the I, and this one is a sp3d2. Okay, then this is a two lone pair. Is a one is top and the bottom. So two lone pair, and the balance four is a unpair. 1, 2, 3, 4. Okay, now so the terminal atom is using the 3p orbital to do overlapping. So now I will draw the 3p orbital. Okay, Cl, 3p, overlapping, sigma bond. So make sure you overlap by n to n. Okay, Cl, 3p. Okay, Cl, 3p. So sigma bond. Okay, Cl, 3p, sigma bond. Cl, 3p, and then sigma bond. Okay, done. So this is a charge negative, so you can make sure you label the charge negative, or you can label the I minus at the center. So this is exactly like the molecular shape, but it just show more detail in the overlapping. Okay, so now finish about the case B. Now I proceed to the case C. So case C is where is a one central atom but involve the multiple bond. Okay, now we review the content is a central atom were hybrid and terminal atom involved in multiple bond like double bond, triple bond were hybrid also. Okay, now this is a example I show you COH2. Okay, now analysis the carbon. So carbon must central atom must hybrid. Okay, so now we check. Answer is a 3 electron pair. How I count the 3 electron pair? 1, 2, and 3. Double bond consider 1, so 3. Trigonal planar, so type of hybridization sp2. And how many sigma bonds? So you can count here. So 1 sigma, 1, 2, 3. So 3 sigma and 1 pi. So meaning that the hybrid orbital I expect to get is a 3 unpaired. Okay, how about pi? So just now I tell you, pi also must prepare 1 unpaired, but the name is unhybrid 2p orbital because this is a carbon, so this 2p orbital. So after we analyze the carbon, how about the oxygen? Okay, hydrogen no need to hybrid because single, but oxygen involved in the double bond. So this terminal oxygen involved in double bond, so they involved in the hybridization. Like first step, I will count electron pair. So lone pair 1, 2, double bond 1. So total is a 3. So trigonal planar. So type hybridization sp2. 2 lone pair, yes, 1 sigma and pi. So 2 lone pair, we expect to get the sp2 with 2 lone pair. 1 sigma is a 1 unpair, and 1 pi is a 1 unhybrid 2p orbital. Okay, now we proceed to the orbital diagram for the carbon. So it's a 2s2 and 2p2. So now we check with the aspect. The result is a 4 unpair. So meaning that I must jump one electron from ground state to 2p to form 4 unpair. So this aspect result is help you to think the process. You should jump or you should remain or not. So after that, the answer is sp2. So I just mix with the sp2 until here. So this one you get the sp2. So this orbital unpair is not involved in the hybridization. So you revert again, but we name the orbital we call unhybrid 2p orbital. Unhybrid is not involved in the hybridization. Okay, now how about oxygen? Oxygen is a 2p2 and a 2p4. 1, 2, 3, 4. 2p4. Okay, so now we check again. I need 2 double bond. Yes, no problem. I need 2 unpair. Yes. Okay, so I just revert again for the excited state. Okay, now I want sp2. So that means I just mix S and 2p. So become the sp2. But how about this one? This one not involved in the hybridization. I just revert again and say unhybrid 2p orbital. So class, after that, you know how to analyze the central atom and the terminal atom, which involve the multiple bond. So after that, I'll show you how to do the orbital overlapping. So this is answer from the previous slide, and the terminal is a hydrogen. So before I start to drawing, right, so the oxygen is a trigonal planar, the carbon also trigonal planar. So if you draw the trigonal planar like this, you can form the overlapping end to end. So what you can do is you turn this trigonal planar become opposite direction like this. Yes, that means here you overlap end to end. So you turn the shape. Okay, now I will start with the carbon first. So carbon is sp2 trigonal planar. So I will draw the carbon sp2. Okay, carbon sp2, sp2, and sp2. So contain the 3 unpair. 1, 2, 3. So the 2 is a H from the 1s. S is a spherical orbital. So sigma 1s H, and this one is a spherical orbital. This is a 1s and the H. Now I'll proceed to the oxygen. Oxygen is a sp2. So now I'll draw another sp2 here. Okay, so this is oxygen. So sp2, sp2, sp2. For sp2 contain 2 lone pair. So where's the lone pair located? Is here. So I will label the 2 lone pair. Another unpair is a function to overlap to the carbon. So this is called sigma bond. Okay, class, so already done all the sigma bond. Now I will draw the pi bond. Okay, so for pi bond, right, is at the carbon contain the 1 unhybrid 2p orbital. So oxygen also contain 1 unhybrid 2p orbital. So to form one pi bond, must 1 unhybrid 2p orbital combine with the another unhybrid 2p orbital to form the 1 pi bond. Okay, now as you know, to draw the pi bond, the p orbital and hybrid 2 orbital is a parallel shape, is a parallel arrangement. So you can draw the parallel shape like this, or you can draw like this, as long as a parallel arrangement. Okay, so now I will draw the carbon for the pi. So I can draw in the center of a start with the center of a carbon, and this one also start with center of the oxygen. So this is a 2p and 2p, each one bring 1 electron, opposite spin. And how you show the pi bond is we label the line. So out and down we label 1 pi. Yeah, so this is called pi bond. So you can see here the C and the O, 1 sigma and 1 pi. Yeah. So the carbon here is bond with the H sigma and H. Yeah. So this is what we call the central atom hybrid and the terminal atom, which is involved in the double bond, triple bond, were hybrid also. So remind you again, one pair anhybrid and one pair anhybrid to become one pi bond. Okay, now so we proceed to the next one is more than one central atom. So this is the last case, more than one central atom. So for more than one central atom, right, all central atom were hybrid. Terminal atom involved in the multiple bond like double bond or triple bond were hybrid also. So today I'll show you the example is a C2H2 where is a triple bond. Okay, now we look at the analysis. So this is a two central atom. If a two central atom, right, meaning that the central atom were hybrid, another central atom were hybrid also. Okay, now we look at the carbon one. So carbon one is a one electron pair and one electron pair. So answer is a 2. So answer is a 2. Yes, 2. So 2 is a linear and SP. So now we check 2 sigma and 2 pi. So 2 sigma and 2 pi. So as you know, 1 sigma, 1 ampere. So 2 sigma is a 2 ampere. So 1 pi is a 1 ampere. So 2 pi is a 2 anhybrid 2p orbital. Okay, now how about carbon 2? So for carbon 2, you can count how many electron pair? 1, 1. Triple bond consider 1. So answer is a 2 electron pair, linear shape, sp. So we count how many sigma bond? 2 sigma and 2 pi. 2 sigma, 2 pi. So we expect to get is a sigma mass 1 sigma, 1 ampere. 2 sigma, 2 ampere. 1 pi, 1 ampere. 2 pi, 2 ampere. So this is what we expect to get. Okay, now we go to the ground state. Carbon 1, C2, 2S2, 2P2. So you check what you expect, you must get 4 ampere. So meaning that you need to jump 1 electron from 2S to 2P. Okay, after that, I need combine sp2, sp2. So that this 2 is considered as anhybrid 2p orbital, not involved in the not involved in the hybrid, but were involved in the pi. Okay, so how about C2? So this one is a 2s2 and 2p2. So same, I need 4 ampere. So meaning that 2s must jump to 2p. So I will draw 4 ampere. Then I will combine sp. Yeah, sp. So these two not combined, right? So we say this is a anhybrid 2p orbital. What's function for anhybrid 2p orbital? To form the pi bond. Okay, now we proceed to orbital overlapping. Okay, so before that we check the carbon is a linear. Linear is like this, and the carbon also linear. So easy. So we just draw the two linear for carbon 1 and carbon 2. So now I will start with draw carbon 1 first. Okay, so carbon 1, so this is a sp, so they bring 2 ampere, so 1, 2. So the first is a ampere is a share with the hydrogen. Where's the spherical shape? Okay, so sigma 1s h. So another sigma is a with the carbon is a sp. So I'll draw another sp. Okay, this is carbon 2, sp, sp. So for sp, contain 2 ampere. So 1 ampere is overlap with the C1 sigma. So another ampere is overlap to the H. okay, to form another sigma. Okay, now I will draw the unhybrid 2p orbital. Okay, so as you know, for form unhybrid 2p form one pi bond must one unhybrid and combine another one unhybrid to form the one pi. Okay, now I will draw at the center C1 and C2 with the one unhybrid 2p orbital first. Okay, so label 2p. 2p, bring one electron out and down and label first. Yes, connection first. So this is your first pi. Okay, so done. So how about second pi? So I change to another color. Whereas, okay, so I'm using the green color. To form the second pi, you must using another unhybrid 2p orbital with another unhybrid 2p orbital to form the second pi. So now I will draw the second pi. Okay, now, so to draw the second pi, so either you draw shift to the right side, parallel, or left side also can. As long as parallel shape slightly. Okay, so now I will start with the C1 first. Okay, now about C2. Okay, so this is a 2p, bring one electron out. This is a 2p, bring one electron down. So you label the using the line to represent the pi bond. Okay, so make sure you label the pi. So out and down only label one times for the one pi. So now you can check C and the C. 1 sigma, 2 pi. And here 1 H and H. Done. So this is for C2H2, where is a triple bond. Okay. Okay. Now, so for this is an example 2 for the case D. For this example, I will just show you how to do analysis. So that's all. So for drawing, you can do it yourself. Okay, let's say you get the answer, the question like this. So where is they give you the all skeleton? Okay, all skeleton and without octet, right? So first step is make sure you count the valence electron is 24 valence electron. So you expand the NH2 become the single bond. So you can count 2, 4, 6, 8, 10, 12, 14. Yeah, 14. So that means you left 10. Okay, now you can check. The N is 6. That means 2 more to achieve octet. Carbon already 8, so no problem. Oxygen O2 is a 2, 4. That means you require 2 more. So oxygen here is a 4. It means you require 2 more. Yeah, so you need to complete your Levy structure first before you proceed to predict the type of hybridization. So this answer I get. So for the same same atom, I label O1 and O2. So this case is more than one central atom, and so central atom N hybrid, carbon hybrid, oxygen hybrid, and the terminal H no hybrid, H using 1s. But terminal O is involved in the double bond, so O will hybrid also. Okay, so O will hybrid also. Okay, so this is case D. Okay, now we study about the prediction. So carbon is a 3, 1, 1, 2, 3. So 3 trigonal planar, sp2, 3 sigma, and 1 pi. So make sure later on you do your exercise, you get 3 ampere and 1 pi. Okay, now how about O1? O1 is a 1 lone pair, 1, 2, 3. So 3 electron pair, trigonal planar. So sp2, so contain 2 lone pair, 1 sigma, 1 pi. So this is a sigma, this is a pi. So that means make sure after you excited state, you must get 2 lone pair and 1 sigma and 1 pi. Okay, now how about O2? O2 is a 1, 2, 3, 4. So 4 electron pair is tetrahedral in the V shape. So it's sp3, contain 2 lone pair and 2 sigma. So this is a sigma. Okay, sigma. So 2 lone pair, later on you do your excitation, make sure you get 2 lone pair and 2 unpaired. Okay, last one is a N. N is a 1, 2, 3, 4. So 4 electron pair tetrahedral sp3. So 1 lone pair and 3 sigma. So how you get the sigma is, so sigma, sigma, and sigma. So that's why 1 lone pair and 3 sigma. So make sure that all you will get the answer is 1 lone pair and 3 unpaired. Okay, so class, this is part D, where it's involved the more than one central atom, and the terminal also involved the multiple bond. So that's why hybrid. Okay, so thank you for sharing. So we proceed to the moderator, Madam Tang, today. Okay. Hi, Madam. Excited state same as promotion of electron, because my lecture call is promotion of electron. Can be same also. Yeah. Madam, do we have to do all the procedure from the electron pair to do the explain the hybridization process in the exam, or we should write only certain things? So if the question asks you to predict or explain the hybridization process, right, you need to give information like from the Lewis structure, molecular geometry, and the electron pair, and the information and type of hybridization. Yes. So if without information, you can't predict the hybrid, you can't predict type of hybridization, and you got problem in the drawing the orbital diagram and the orbital overlapping also. So maybe if the question asks to draw overlapping, right, should we write also the excited state and hybrid state? Okay, usually, right, usually they will ask you explain the hybridization process. If hybridization process, right, usually you need to give more or all information. So sometimes they will tell you more clearly. Let's say they'll ask you to draw orbital overlapping and the orbital diagram. So means you need to give all. Yeah. So if the molecule have negative ion, for example, IF4 minus, should we have to add another arrow, and the arrow need to be moved to the 5D platform, right? Arrow need to move to the 5D platform, right? Okay, so you means in the ground state, excited state, so the arrow just help you to understand how many electron move only. So if you show it is better, like you don't show also okay. So whether is it a must to write orbital overlapping for terminal atom? Okay, so Sophia, you can check the notes I give you in the telegram. For part B, case A is a no hybrid. For case B is a one central atom and the single bond. So the single bond no need hybrid. For case C is a one center and the and involve multiple bond. So the atom involved in multiple bond were hybrid. Okay, so part D is all all central, more than one central atom. So the more than one central atom, right, all the central atom will hybrid, and then the terminal atom, which is involved in the double bond or triple bond, you must hybrid. So what is the difference, IF4 minus and IF4 plus? So I think the shape will be different. So you can count your Lewis, count your valence electron first, and then you check how you draw a Lewis structure. You check the molecular geometry. Maybe will different. I think different class of the molecular geometry. Yeah, minus and plus just in the check when you check during the excited state, enough electron or not for excited state. We don't need to write the bonding angle in orbital overlapping diagram, no need. So usually angle will draw in the molecular geometry. So the molecule that have a more than one central atom, we must know the molecular shape for each central atom, right? Yes, just now example I show you, right? The NH2 C double bond OOH, right? So when you draw, right, the N should be draw tetrahedra, the cup should be draw trigonal planar, the O1 must draw trigonal planar, O2 must draw tetrahedra. Then you will see the one picture where it's a different shape in the overlapping. So maybe you can show your answer and post to Telegram. Maybe I will help you to check your answer okay or not. Okay, thank you, Arif. So Maiden, do we need to explain all the process in sentence or just write like Maiden showed or a slide if the question asked to describe? Okay, all right. So answer the question, right? Usually, the table I give you just a guideline like how you answer the question. So if answer question, usually we write the sentence, electron pair of central atom is 5, molecular geometry is what, using the sentence. So, thanks for making so teacher. All right, really help. Okay, so the technique I share with you, analysis, actually is to help you to plan. To plan, you should jump, you should promote, or how many electrons you should promote, or no need to do anything. Also okay, right? So it's help you to think further what you should do for the next step. So thank you. Madam, must we show the calculation for former charge? Okay, so okay, this question is 4.1. So if a question asks you to prove it, show it, it's better you show it lah. Okay, then it's okay. Madam, for the hybridization explanation, do we need to draw or just a case or just follow question cause sometimes a mismark on this hybridization? Depends to question. Sometimes they will give you information very clear, like they'll ask you to show orbital diagram. So orbital diagram only. For if they ask you to determine the hybridization, so I think you must start from Lewis, molecular geometry, and give the information and answer the question. So because sometimes without the Lewis structure or molecular geometry, you can't predict your answer. So I think sometimes you look at the question, if they ask you to expand the marks more higher, so you just give more information. Then we need to show formal charge or not. Okay, so sometimes we don't know how the marking, so you just show how to you get the formal charge to double check. If sometimes we don't mistake, right? So you can double check again your formal charge okay or not. Yeah, just show you only, never mind. Hi, Maiden. How to determine the molecule have more than one central atom? All right. Okay, the one central atom like the okay, let's say AlCl3 one central Al. Let's say C2H4 C2H4 this two center. Let's say your amino acid NH2 C. The center is in the center, right? In the center contain how many center you call more than one central atom. Let's say the case I show you just now about the amino acid, right? So the N is the center, the carbon also center, another O is the center also. Then the H at the terminal, the H we call terminal. Okay, so the O double bond, O also called terminal, but the O is involved in the double bond. That's why they involved in the hybrid also. It's the same. Yeah, I using underline is a simple and no need to waste your time. So because orbital diagram can be box or line. The one that involve more than one central atom, how to determine the position? What's meaning by position? More than one central atom, how to determine the position? Okay, so usually hopefully they give you in the skeletal structure. Usually they give you a skeletal structure so that you can know how they arrange each other. Okay, so far like the carboxylic acid, so they will give you C double bond OOH. So center is a carbon. So you need to go through a few examples so that you know how to determine the position of the central. Central is a central and bond with the terminal, we call central. Later, if the question say explain orbital overlapping of certain compound, should we explain in word as well, or is using the orbital diagram sufficient? So yeah, I know because sometimes if the question is asked about explain the hybridization process, or they ask the explain the formation or the bond they form. Okay, so it depends on question. Sometimes explain orbital overlapping of certain compound. Usually, explain orbital overlapping, you need to show from the Lewis until orbital diagram and the orbital overlapping. But of course, sometimes they need you to explain in the word about the bond form. Let's say example, BeCl is sigma bond formed by the sp2Be and the S 3p orbital, something else. Yes. So I think you need to write. If you're not confident, you can write all. So for the explanation hybridization process, if we want to write in the where, you should, instead of writing in sentence, still acceptable, right? Oh yeah. So you can write central atom of chlorine is electron pair of chlorine, electron pair of the central atom barium is what? So it's like this. Not in the table. Table just I help you to do the summary and the discussion. Madam, why do we need to molecular geometry? Okay, so this good question. Actually, molecular geometry, right, how they arrange will affect the property of the molecule. If water today is arranged in a linear shape, I think water is a big problem to us, because if water arranged in the linear shape, that means water is non-polar. So as a biology student, if water non-polar, they affect a lot of the things in our body and in our environment. Yeah, so molecular geometry actually is important for us to predict whether molecule polar or non-polar. So whether can we do it in table form? It's better doing, so better you write the sentence electron pair for central atom barium equals to 2, type of hybridization equals to sp2, like this. Yeah, table just I help you to do the understanding. For the explanation hybridization process, if you want to write in the where, you show instead of writing sentence, still acceptable, right? Okay, you must write the full sentence. So Maiden, how to know how many electrons need to be moved? Okay, so you can follow, you can check again the video I show you. So you can predict the your excited state. So if a one lone let's say a one lone pair, you can predict first your excited state, and then you go back to your ground state. So you check whether same or difference. Okay, never mind. The case for the central atom more than one, like two central atom, the two central atom will be always be two same atom, for example, CC and N. Okay, so usually case like this more than more than one central atom, right? So all central atom will involve hybrid. Okay, thank you, Maiden. Okay, thank you.
Okay, so any more questions from the students? So if no, then do remember to fill in the feedback form that is pinned in the YouTube live chat. Okay, so do remember to fill in the feedback form so that we can improve on this program. So thank you. So thank you, Madam. Okay. So any more questions? Students, any more questions? Okay, so if no more question, do remember to fill in the feedback form for this slot so that we can improve on this program. So if no question, then that's it for today. Do remember to subscribe the Magic Revisions channel so that you can get the update on the next session's class. Okay, so that's it for tonight. Thank you. Oh,
Thank you, student. Thank you.
there's last question. There's a last question from Manjura.
Okay. Okay, no, orbital overlapping must follow the exactly like the molecular shape. Yeah, cannot follow Lewis structure. That's why I teach you must step one Lewis, step two molecular shape. Yeah, thank you.
Okay. Any more questions? Any more questions, students? So if no, then the next slot will be on 28 December for physics. So do remember to tune in on 28 December to be with Mr. Shakil. So for the physics class. So if no more question, then that's it for today. Thank you.